Hello everyone, welcome to Next Round Coding. Today we're going to solve LeetCode 3952 maximum total value of covered indices. This is a LeetCode medium problem, and this problem is recently asked in LeetCode by click on test 184. So in this video, we will try to solve this problem. First of all, we understand the problem, then we build our intuition and approach, and later we will see code in C++. So let's understand the problem first. So the problem states that we have a given a nums array and a binary string s. If the binary string is contains 1 at any index, then there will be a token. And if it is contains 0 at any index, there is a no token. Okay. Now, we can do some operations over here. If the index has a token, we can shift the token to its previous index. Suppose case is something like this. Now, this index have a token because it is a1. Now we can shift to its previous one, and we can do it only once for this one. So we can do it like this. This operation is good. Now if we want to do it again for this one, if we want to do it this way, it is not possible. But this one is untouched. We can do it for this. So 1 0 0 1 0. This is good. So for each one we can pass the token to its previous one. Will be done only once. And after this operation, we can do this operation as many times as we want. And after this operation, we need to return the maximum total sum of nums which have the token indices. Suppose for this case, if we do now operations, then the token indexes will be this one and then this one. So this will be our token indexes. So it will be the sum 2 plus 1, it will be 3. And if we do the operation like this one to this previous one, this one to this previous one, it would be 1 0 1 0. Then it would be our sum would be 9 and 6 because there is 0th index and second index. So 9 will be 0th index and 6 in the second index. So 9 plus 6 it will be 15. And for this case, 15 will be our answer. So this is the maximum one for this case. So I hope the problem is clear to you. Now let's see the approach. So we have a nums array and we have a string. And as you know, our task is to maximize the sum of the values in the indexes which have token, right? So for every index, we want to decide whether this index should contribute to my answer or not. Now, how a index can contribute to my answer? Suppose this index can contribute to my answer or not. This index having 0, right? So if it is having 0, it doesn't hold any token and it can't take a token from its rights because in the right it has 0. So this index can't contribute to my answer. Now come to this index. For this index, again it's hold 0, but in its right having a 1. So this index can contribute to my answer, right? And if we go next for this one already having a token, so this can also contribute to my answer. But we can take any of them, means we can't take both of them. We can take either this one or this one, right? So what is the condition of contributing in my answer? So if our s of I is having a character 1, then it can contribute to my answer. If our I plus 1 is the character 1, then it can also contribute to my answer. Now, as I told you, that if this was taken, then for the next index, we can't take it because the token is shifted to its left. So we need to know that this token is shifted to its left or not, right? So for knowing this token is shifted to its left or not, we need to take a variable. Otherwise, we can't memorize it, right? So what we'll do, just take a function and there is a current index. okay, which I am processing, and take a variable taken. What does this taken told us? If the taken is 0, then it told us that this index is not taken yet. Okay. If the taken is 1, that means this index token is already shifted to its left. We can't take it. Right. So we have a taken variable which told us that this index token is already taken or not. Right. Okay. Now this is done. Now, as we need to maximize our answer, what are the choices we have? So first choice we have that we can skip our current index, right? We can, if we want to skip it, we can skip it. For this case, having 0, we can just skip it. Okay. Now, what will be our next choice? Our next choice will be if the token is already present there. So token is already present. Something like this. This one. One is already there, so token is already present there. So this can be a choice. And our third choice is that our moving choice means move token and idx means index I plus index plus 1 to index. Right. These three choices are over there. So now suppose our answer or name it as best. If we skip it, then our function will be something like this. Just index plus 1 and taken 0, right? Because we have not taken it. So it is 0. Now for case 2 means choice 2, it is only done if our s of I is a character 1, then we can only, then the token is already present there, and our taken is not, means we have not taken it, right? Then we can take it to do our best as the maximum of best comma nums of I, right? Plus our function I plus 1 and our taken would be 0, right? This is done. So this is for one choice, this is for choice 2. Now come to choice 3. Now choice 3 is only done if our I plus 1 is lesser than n and s of I plus 1 is 1, right? Then we can only do that. So it is 1. Then we can do our best as maximum of best from a nums of I plus func of I plus 1. Now the taken would be 1 because the token at index I plus 1 is shifted to its left. That's why for the index I plus 1, there is no token. That's why we need to put a1 over here, right? So we have finished 3 choices. At the end, we just then return or best, right? Now, so our state is something like this, just function of index and taken, right? These two are variable parts, right? Now, as you can see, these states are repeatable. So if the states are repeatable, then we can easily do a memoization over here. We just build a 2D array of DP. So we can just build a DP array of index and taken. And taken only have two values 0 and 1. So this will be just taking n into 2 size array, right? And what does this DP array will state? This means the maximum answer from index onwards with current position is taken or not, right? So DP of index are taken will state that maximum answer from the index onwards with current position is taken or not, right? This way we can just do the memoization and then do these choices over here one by one, and at the end we can just return our answer best. We can get our answer. So I hope the idea is clear to you. Now let's see the code. Okay, now let's see the code. So we need a function, long function. We need an index, our vector nums and string s, and a variable token taken. So first of all, the base case. So we have a n which will be nums dot size. Now if our index is greater than equal to n, then we will return 0. Right. Now our first option, keep it. So our long best will be function of index plus 1 nums, yes, and token as taken as 0. Now our second option, token already there. So in this case, if our s of index equal to character 1, and if it is not taken yet, so not of taken, then our best would be maximum of best, comma. We will take nums of index, right, and plus our function index plus 1, comma num, comma s, and taken as 0. Now third option, if we move from I plus 1 to 2s. For this case, first of all, we need to check s of index plus 1 is equal to character 1 or not, and also need to check index index plus 1 lesser than equal to n, right? Otherwise it would go out of bound. Then let's do best equal to max of best and nums of index plus our function of index plus 1, comma nums, comma s, but the taken will be here 1 because we have taken for the next one, right? And at the end we will just return our base result here. Now let's call the function over here. So function of 0, comma nums, comma s, comma taken as 0, and then run it up. Oh, sorry, there will be return. Yeah, so run it up. It is running fine. Now we need to memorize it. So for memorization, we need to declare a vector of vector, find the dp. Now assign the dp over here of n, comma vector of long of 2, comma minus 1, and it would be long as well. And our n need to be declared over here, right? And here we need to check if it is already pre-computed or not. So our dp of index and taken is not equal to minus 1. then just return dp of index and taken, and assign the dp of index and taken here. Yeah, that is all. Now just run it. You can see it is running fine. Let's submit it. Yeah, it is accepted. So the time complexity of this approach is big O of n, because we are just going for each index in the nums array, and the transitions are not taking that much time. It is just big O of 1, right? So that's why it is big O of n. And space complexity, again, it would be 2 into big O of n, because I have taken 2 into n size array, which is nothing but big O of n as well. So that is all. So if you have any doubt, you can comment me out. And if the video is beneficial for you, please do like and subscribe. Thank you.